is everything that you're going to be assessed on in this test, okay? This is everything that you can be asked, and we're going to go through every single one of these to explain clearly what it is, and so it's your job to make sure you understand what those words say and that you can do that skill. And if you can do all of that, there's no reason, bar simple mistakes, you won't get 100% on the test, okay? So if you can do all of that, you get 100%. Then right at the bottom of the page there, I've got the chapter review questions. So in the textbook, at the end of chapter 1, there's the chapter 1A review set, chapter 1B review set, and I've got the selected questions there that I recommend you have a go at. And then if we turn the page, this is what we are going to do today. This is sort of my direct teaching. This is going to be a very clear summary of all of the things we've gone through. It's going to address everything, and we're going to go through it together to really emphasize what sort of skills and techniques we're looking for. So hopefully this sort of recap, hopefully you find it sort of consoling. Yep, I know how to do this, and that's going to set you up well for revision. That's what we're going to do today. On Thursday, so in 2 days' time, we're going to do a formative test. It'll be sit down, I'll give you a test paper, we'll work in silence, have a go at that. And then on Friday, we're getting a pretty rough deal here. We've got Clean Up Australia Day in the first half of the lesson. So then we'll get the second half of the lesson to catch up and talk about that formative test. Tuesday, another revision lesson. Maybe some of you will be doing the test there. And then Thursday, next week, the test. All right. And here's the other thing is, like, we're going to be going through this list, and hopefully this points out to you, hopefully the list goes, that's a skill I need to practice. That's a skill I need to develop a bit. And so that's where you're going to put a mark down, let me know, communicate that to me, and I can point exactly where you need to look that up. Okay, let's get straight into it anyway. So question 1 here, so I encourage you to work through these in your book. I've just written the questions here, I haven't left any room for you to do them. But we've got question 1 here. Consider the coordinates. We've got 2 coordinates. We've got x is 2, y is 2, and x is minus 2, y is minus 10. And we're going to do everything we did in the linear equations booklet in this question, okay? So the linear equations booklet is cropped from the year 10 textbook of last year, and it's going to cover all of those first dot points, all right? So if you look, question A says find the distance between these coordinates. That's exactly what the first checkpoint on the list is. So for the distance, we need the distance formula, which is the square root of x2 take x1 squared plus y2 take y1 squared. All right, we can also see that from our notes book. Now, we've said in the test, you're not going to get you're not going to have a cheat sheet to take in, but anytime you're required to use a formula like this, we would provide it for you, okay? So here's distance between 2 points. All right, and so what we need to do is we need to go through and label them, x1, y1, x2, y2, and just smash it into the formula to evaluate it. So we're going to have minus 2 take 2 squared plus minus 10 take 2 squared. All right, so all I've done there is put the numbers in their respective positions. All right, so this is from 11A in our notes book. This is what we started with. Let's evaluate that. We've got minus 4 squared plus minus 12 squared. So that's going to be 16 plus 144, 160. Okay, so the distance between these 2 points is the square root of 160. And so the other thing is we're not using a calculator in this test, and so you're not expected to evaluate anything like that. All right, so if it helps as well, like if you feel like you got that skill, you can put a tick here. You could write down 11A. That's where it corresponds with in our notes book. You could also write down question 1A. because that's the question it corresponds with on the back of the sheet. So if you're unsure about that, or that's a skill you want to develop a bit more. Okay, let's move on. We've got find the midpoint between these coordinates. So the midpoint formula, this is from 11b, is x1 plus x2 on 2, comma, y1 plus y2 on 2. Now notice how I've got this comma in the middle? That's because it's a coordinate. It's a coordinate, and all it's saying is it's the average of the x coordinates and then the average of the y coordinates. That's going to generate for you the coordinate that lies exactly halfway between them. So we're going to have 2 plus minus 2 and 2 plus minus 10. All right, we'll evaluate these. 2 take 2 is 0. And 2 take 10 is going to be minus 8. All right, and then in simplest terms, 0 divided by 2, 0. 8 divided by 2, 4.
Minus 8.
Minus 8, thanks Kevin. All right, on to part C. Find the slope between these 2 points. All right, so I've used capital M for midpoint. I'm going to use lowercase m for the slope. Slope formula, y2 take y1 on x2 take x1. So this is a formula you do need to remember. All right, so I don't expect you to remember distance. I don't expect you to remember midpoint. You do need to remember the slope formula. y2 take y1 on x2 take x1. So if you want, write down remember this or something like that. Okay, find the slope. So we've labelled them already, and that's been the beauty of it. It's allowed us to just substitute them straight in to each of the formulas. So for the slope here, we're going to have y2 take away y1 divided by x2 take away x1. We've got minus 12 divided by minus 4. So it's going to be positive because we have a negative divided by a negative, and 12 divided by 4 is positive 3. All right, so if we look back at our skills checklist, we've done the distance between the 2 points, we've done the midpoint between 2 points, and now we've done the slope between 2 points. So that was the first skill, that was the second skill, that's the third skill. All right, next we have find the slope of a perpendicular and a parallel line. That's the checklist. Let me read the question. Find the equation of a line that goes through these coordinates. So we learned both y-intercept and general form. You're only required to know y-intercept form. Okay, general form is something that's going to pop up a bit later in the year when we're doing calculus. And a little bit later if you move on to year 12 methods as well. So y-intercept form, we want to find the equation of a line, and the equation of a line is y equals mx plus c. Okay, that's the equation of a line in y-intercept form. So we're expected to know that one. All right, and we've established that the line through these coordinates has a slope of 3. So we're going to have y equals 3x plus c. Now, please stop me at any stage if I'm going too quick or if you have any questions pop up. Kevin, are you all right? Can we put your laptop away?
Yeah.
All right, y equals 3x plus c. So then we want to find this c value, and we're going to substitute in either of these coordinates. Either is fine because both of them exist on the line. Both of them are going to satisfy the equation. I'm going to do that one because it's, they're both positive. Don't have to think too much about the negatives. So I'm going to put 2 where the y is and 2 where the x is. All right, 3x means 3 times the x value. And now we're going to go through here and solve for c. All right, subtract 6 from both sides. We've got minus 4 is c. Not done there. okay? Because you need to answer the question. It happens all the time. Kids will get to here and they say, finished. No, you've got to say, what's the full equation? Answer the question. Y is 3x, take away 4. All right, are you writing down notes or something? Yeah, okay, you can do that if you want. That might be a bit slower. See how you go. All right, move on to the next skill then. Graph the line you found in D. All right, so I'm going to just provide a rough sketch of it to remind you how we do it. First, we plot the y-intercept. So the y-intercept is at x minus 4. All right, the slope and the y-intercept. This component here is the y-intercept. So we have a y-intercept of minus 4, and we have a slope of 3. And remember, we need to express the slope as a fraction, all right, don't we? So 3 by itself is 3 on top of 1. Sometimes it will already be presented to you as a fraction. Now what that means is it goes across 1 and up 3. Remember, slope is the change in y divided by the change in x. All right, y2 take y1 on top of x2 take x1. So we're going across 1, up 3. Across 1, up 3. And so that's how we're going to plot it on a graph. You'll have coordinates there. That's got a y-intercept of minus 4. This is 1, minus 1. This point is going to be 2, 2. And it keeps going. All right, so if that's a skill you need, you need to practice, note that down. All right, so graph the line. Okay, very good. F. Find the equation of a line perpendicular to the line in D. So here we have the line we found in D, and we want to find a line perpendicular to it. So this is how it works, is if a line has slope A on B, then the perpendicular line has slope negative B on A. We call that the negative reciprocal. So our line here we saw had a slope of 3, or as a fraction, 3 on 1. So that means our perpendicular line is going to have a slope of minus 1 on 3. All right. Okay, so I'll rub out the first one here. Okay, so we're finding a perpendicular line. So that means this line has to have a slope of minus 1 on 3. So we're going to have y equals minus 1 on 3 x plus c. This is going to be our perpendicular line. But what other information are we told? Find the equation of a line perpendicular to D, but it has an x-intercept of minus 12. Okay, so we've got to think about this. What does this mean? It's not the y-intercept. If it was the y-intercept, we could just chuck it there. Okay, because what is c but the y-intercept? We're given the x-intercept. And so if the x-intercept is minus 12, what is the corresponding y value?
0.
0. Very good, Mason. The y value is 0. And so we're going to put, it goes through this point. The x-intercept is minus 12, the y value is 0. So we're going to put 0 where the y is, and minus 12 where the x is. And we're going to evaluate these. Okay? 0 equals. Now, here I've got a negative times a negative. So that's going to be a positive number. And I have a third of 12. Now maybe you can't think about what that is in your head, but what you can do is just write it's the same as 12 on top of 3. All right? 1 times 12, 3 times 1, 12 divided by 3. So we've got 4 plus c. All right? Take away 4 from both sides. C has to equal negative 4. All right, so this line then, we determine the value of C, but answer the question. What is the equation of the perpendicular line? Minus a third x, take away 4. Okay, so we've got, here's our first line. Here's our second line. Now, part G. Determine the coordinates where these lines meet. Determine where they meet. So there's a couple of ways you could do this. One of them would be to graph both of them. We've already graphed the first one. We could just graph the second one. We can actually see, just by looking at them, where they meet, actually. Can anyone see? Just by looking at those two equations.
Yeah, the y-intercept's the same.
The y-intercept is the same, which means they both cross the y-axis at the same point. All right, and if it's a perpendicular, I'm just going to draw it roughly, but if it's a perpendicular line, that means it meets at 90 degrees, right? So it's going to look something like that. It's got an x-intercept of -12, okay? The y-intercept is the same, which means we can see intuitively that they meet at x is 0, y is -4. That's where they meet. Nonetheless, let's perform the algebra. Okay, let's show you. We want to know, when does y equal 3x take 4? And y equals a third x take 4. When do they meet? When are these lines equal to one another? All right? So the way you determine when lines meet is you just make them equal to one another. We're going to go 3x take 4 equals minus a third of x take 4. All right, and we're going to solve this. This is the equation. This is the question we're going to solve. No, you can open your book, start writing some stuff down there. Come on. Okay, so what we want to do is we want to get the x's by themselves and the numbers by themselves. So, first thing I'm going to do is add 4 to both sides, and I'm also going to add a third of x to both sides. I'm going to do it in one step, but I might write some colours up so you can see clearly. So I'm going to plus 4 on both sides, and I'm going to plus a third of x on both sides. All right, so here, -4 plus 4 cancels, -4 plus 4 cancels. And then we've got 3x plus a third of x. This one I'm going to do nice and slowly. And over here we've got negative a third of x plus a third of x. That's going to cancel as well. So we're left with 0 on the other side. Okay, so from here, again, you can see the only value of x that's going to make that true is 0. But let's continue on and we'll look at the fraction operations, okay? So like an equation is a truth statement, and it's saying the left side equals the right side, and there's the only number that you can substitute in here to make this side equal 0 is the number 0. 3 times 0 plus a third times 0. We're going to have 0 on the left, 0 on the right. But nonetheless, let's go through and prove it. Okay, we've got 3x plus a third of x. To add them together, they need to have the same denominator. All right. So the way we should think of it is we've got 3 plus a third. So how do I write 3 with a denominator of 3? It's 9 divided by 3, right? 9 divided by 3 will give you 3. All right. So we've got 9 on 3x plus a third of x. Okay. So I have 9 on 3x plus a third of x. Because they have the same denominator, you can add them together. 9 on 3 plus a third, 10 on 3x. All right. And then the way you get x by itself is we're going to multiply both sides by 3 on 10. Okay? Because then what's happening here, why 3 on 10? It's just the reciprocal of this. I've just flipped it. All right, because when I flip it, we've got 3 at the top, 3 at the bottom, that'll cancel. And we've got 10 at the top, 10 at the bottom, that'll cancel. And 0 times 3 on 10 is 0. Okay. You can see that it's 0 in this step, but I just wanted to demonstrate those fraction operations and take them a bit further. That's quite tricky. All right, so that's the first question. That's everything we did in the recap of lines. Okay, so you saw hopefully the earlier skills were pretty okay, and then as we moved down, they got a bit more complex, didn't they? All right, so let's go on to question 2 then. We got Telstra charge a $1 connection fee and then 30 cents for each minute of a phone call. Vodafone charge a flat rate of 50 cents per minute. Fill in the table. All right, so we got Telstra, Vodafone, and we're giving you a few numbers, and we've got minutes 0, 1, 2, 3. So for 0 minutes, Telstra costs $1. For 1 minute, they're going to cost $1.30, $1.60, $1.90, okay? Vodafone have a flat rate of 50 cents per minute, which means for 0 minutes, they cost 0. For 1 minute, 0.5, 1, 1.5, etc. All right, so hopefully we understand how we generated those answers. Okay, which of the lines is in direct proportion? Justify your answer. So you should remember from equations of lines, if it goes through the point 0, 0, it's in direct proportion. Okay, we call that direct proportion. But if it doesn't, if it has a y-intercept that is not 0, then we call it indirect proportion. Okay, so the question is, which of the lines is in direct proportion? It must go through 0, 0. All right, so we can see Telstra goes through 0, 1, but Vodafone goes through 0, 0. So the answer, which one's in direct proportion, is Vodafone. Okay, so 1 mark there for the answer, and then another mark for the justification, because it passes through 0, 0. Okay, part C, determine the equation of both lines. All right, determine the equation of both lines. So we're given some subscripts over there for us to use. So for instance, I've got the cost of Telstra, all right, the cost of Telstra, and it's going to equal some slope times the time plus the y-intercept. Okay, so the only difference there to the equation of a line, y equals mx plus c, is I'm using t instead of x to denote time in minutes, and I'm using ct. The cost for Telstra is equal to some slope times the time plus the y-intercept. Okay, so for Telstra, we can see when time is 0, the y value is 1. So we know the y-intercept. The y-intercept is 1. So for Telstra, we're going to have mt plus 1. All right, you can get the y-intercept from looking at the table. And then m is the slope. Another word we have for that is gradient. Another word is proportionality constant. How much is it increasing by each time? Telstra is going up by 30 cents each time, isn't it? So we can put 0.3 t plus 1. Okay, so that's the equation for Telstra. And look, I've explained my reasoning, and so I've got sort of 4 things written down, but this is a 1 mark question, and you get full marks for just writing that. Okay, so we can get it from just intuitively. Another way you can get it is the process we used when we first did the equation of a line. It goes through the coordinates 0, 1, and it goes through the coordinates 1, 1.3. You could pick any of them, and we can find the slope. Okay, if you evaluate the slope, 0.3, you can find the y-intercept, well, it's given to you here, and so that's the same way of generating the equation of the line. All right, so that's the Telstra line. Next, let's do the Vodafone line. And we might do this one a little bit quicker. So we've got the Vodafone line. Has a y-intercept of 0. All right. When time is 0, the Vodafone cost is 0. So if I've got the cost of Vodafone, it's going to equal, I'll write it out like this again, mt plus c. And what c is 0 because the y-intercept is 0. So that means we're just going to have mt. And m is the proportionality constant. How much is it increasing by each time? 50 cents. Sorry? 50 cents, yeah, very good. Thanks, Harry, very good. 0.5 t. All right, so that's the Vodafone equation, and we've got the Telstra equation there as well. Okay, determine the equation of both lines. Graph them both on a Cartesian plane. So if you were to plot these on a Cartesian plane, right, we're going to have time on the x-axis, we're going to have cost on the y-axis. All right, and you're going to have Vodafone. The first point is 0, 0. The next point is 1, 0.5. Then you have 2, 1, and 3, 1.5. All right, so what have I? You'd have to sketch the axes here. I've got 0.5, 1, 1.5, 1, 2, 3. So that's the Vodafone line, and then the Telstra line is going to start here. All right, because it has a y-intercept of 1, but then it's going to be at 130 and then 160. All right, so they're going to intersect at some point, but we've got them both graphed there. That's how we would do a rough sketch. Okay, any questions so far? So we have an option to recap one of those skills again. Determine the point of intersection of these lines. Determine the point of intersection. So I said these are going to meet when they equal one another. So you could determine it if you kept graphing it. You could determine it by continuing the table. Let's do the algebraic process because this one's going to be a bit easier than the one we just did before. So we have 0.3t plus 1. All right, that's the Telstra equation, equals the Vodafone equation, 0.5t. And we're saying, when are these equal to one another? All right, what's the value of t that makes them equal? And so you can do anything, you can do it anyway. To start with, I'm just going to write it the opposite way. All right, all I've done there is put them on opposite sides of the equals equation, and that's just because I like to keep the variable on the left. All right. Next, what I'm going to do is subtract 0.3t from both sides. All right. So I'm putting the variable on one side, right? So here, 0.5t, take away 0.3t, that's going to be 0.2t. And over here it's cancelled. I'm left with 1. All right. And to get t by itself, you can think about it two ways. We divide both sides by 0.2, or you can think of, how can I make that equal to 1? All right, you're multiplying it by 5, right? 5 times 0.2 and 5 times multiplying both sides by 5 is going to give t equals 5. At 5 minutes, they are both equal in cost. All right, so who would be cheaper before 5 minutes? If you have a phone call that's for 4 minutes, this one, okay, you can see the cost is lower. All right, however, after 4 minutes, Telstra is going to be cheaper. All right, so they meet when t is 5. Before 5 minutes, Vodafone's cheaper. After 5 minutes, Telstra will be cheaper despite the connection fee. All right, so that's where they intersect. The significance is that's when the cost of both phone companies is equal. Okay, so if we just flick back to the checklist, all right, what we've done there, we talked about the distinction between direct proportion, have to go through 0, 0, and indirect proportion. We have find the equation of a line from a table of values, and we've used the notation that the question has given us, right? Telstra is CT, all right, T is in minutes. What was next? Plot the coordinates on a graph. Okay, so maybe the trickiest part there is sketching your own axes, but yeah, make sure you get that. Determine the point of intersection, so you can do so from the graph, or you can do so algebraically. And all right, the next skill is in the next question. The next two skills are in the next question. Okay, so let's move on to question 3 then. The time taken to mop the floor is inversely proportional to the number of people mopping the floor. So, equations that are in inverse proportion have this form. Y equals K on X. All right, that's the form that an inverse proportion function takes. So the first one says to fill in the table alongside, doesn't it? So we have the minutes on the y-axis and the moppers on the x-axis. And we've got 90, 1, 45, 3, and 22.5. Okay. So, because it's inversely proportional, what we can see is if we have 90 minutes for one person, 45 minutes is going to be for 2 people. All right, 2 people are going to do the job in 45 minutes, 3 people in 30 minutes, and 4 people in 22 and a half minutes. So what you can see is 90 divided by 1 is 90, 90 divided by 2 is 45, 90 divided by 3 is 30, 90 divided by 4 is 22 and a half. So that's how we can fill in the table. The other justification we have is that if y equals k on x, then k equals x times y. If we multiply both sides of the equation here by x, we can develop this truth for the inverse proportion. And so what that means is notice how every x value times every y value, 1 times 90 is 90. I'll write it. 1 times 90 is 90. 2 times 45 is 90. 3 times 30 is 90, etc. You can see that every x value multiplied by its corresponding y value equals 90. Thus, it is in inverse proportion. What's the value of k? 90. So the equation then, okay, if this is the default function, inverse proportion function, then our function here, this particular function, is y equals 90 divided by x. Okay, so part A, part B done. That's the equation of it. Part C, plot them on a Cartesian plane. So if we need to plot these points right, here's the tips, okay? We're given the x and we're given the y. So I'm going to have moppers on the x-axis. And that makes sense because this is our independent variable. All right, so you can think of science, independent variable. That's the thing, it doesn't depend on the number of minutes. Whereas the time it takes is going to depend on, that's on our y-axis, it's going to depend on how many moppers are mopping the floor, right? And so on our x-axis, I'm starting at 0 and I'm going up to 4. And on our y-axis, I'm starting at, what's my highest value? 90. So I'm going to put 90 there. And the thing here is you must have a scale. So you can't do something like this, 90, 45, 22.30. Like that doesn't make sense as a scale, okay? If this is 90, then halfway is 45, all right? And if this is 90, then a third of the way is 30. And so then 22 and a half is a quarter of the way. All right, so those points are going to be a little bit closer together. So you just absolutely have to have a scale. Doesn't need to be perfect, just needs to be approximately right. And then we're plotting the points. The first point, x is 1, y is 90. The second point, x is 2, y is 45. The third point, x is 3, y is 30. And 4 and 22.5. And that's what we expect reciprocal functions to look like, okay? Inverse proportion functions, they follow that trajectory. Okay, so we finished question 3 there. Any questions so far? All right, so you can see it's a bit of a slog, but we're getting there. It's going to pay dividends. Okay. So those those skills we went over were the last two for chapter 1. Find the equation of a reciprocal function from a table of values. Done. Sketch graphs of lines and inverse functions, clearly displaying asymptotes. So the asymptote one's not something we're testing explicitly, but we have an asymptote occurring here, a vertical asymptote occurring here. Why? Because you can't divide by 0. All right, we can't divide by 0. Anytime we're dividing by 0, that's when asymptotes occur. Okay, so let's move on to question 4. Here's our function. We've got x plus 2 times x take 3 on top of x take 1. Step 1 says evaluate f of 2. So this is from exercise 3b. This is function notation. And so all that means is you substitute 2 into the equation. It's going to be 2 plus 2. 2 take 3 on 2 take 1. Okay, you're substituting x is 2 in, and let's evaluate it. We're going to have 4 times minus 1 divided by 1 minus 4. All right, what does it mean? When x is positive 2, we substitute positive 2 in. The corresponding value of the function, the y value, is minus 4. Okay, find x such that f of x is 0. Now this is a good example because this is what we call a rational function. It's expressed as a ratio. We have one part on top of another part. Now, what you should remember is if we have a function as a rational function, it's going to equal 0 when the numerator is 0, and it's going to be undefined when the denominator is 0. Okay, and that's because we can't divide by 0. All right. So that's an important property. So to answer part B, find x such that f of x equals 0. All right, we're saying when does this equation equal 0? Well, based off of this definition, it's going to equal 0 when the numerator, that is the top of the fraction, is 0. What's the top of the fraction? X plus 2 times x take 3 equals 0. And we're going to apply the null factor law, right? So if a times b is 0, then either x plus 2 is 0 or x take 3 is 0. You don't need the brackets. All right, subtract 2, x is minus 2, or add 3. And what you can see is if you put any of these numbers into this equation, it's going to evaluate it to 0. These are the x values that make the function equal to 0. They are what we call the roots, the zeros, the x-intercepts, right? Those are the words we've been using to describe them. All right, so there are our roots. That's part B. Part C, find x such that the function is undefined. All right, so here's the function. It's going to be undefined when the denominator is 0. When the denominator is 0, so undefined when x take 1 equals 0. So it's going to be undefined when x is 1. Okay. Part D. Hence, draw the sign diagram. Okay? So we've used all of this information. We're going to use all of this information to draw the sign diagram. We know it equals 0 at these points, and we know it's undefined at these points. So let's draw that on a sign diagram. Our sign diagram is going to look like this. We've got the points minus 2 and positive 3. That's where it crosses the x-axis. And we have an asymptote at 1. That's all the information we're going to put on. All right, minus 2, positive 1, positive 3. We can clearly distinguish between the roots and the asymptotes. All right, now we have to make a mathematical argument to determine is it negative or positive in that region. And you can start anywhere, right? You can start here, you can start here, you can start here, you can start here. But we have to substitute 4 numbers in. Let's start when x is 0. All right, so I'm looking in this region and I'm going to determine is it positive or negative in this region. We're going to have f of x or f of 0, when I put 0 in, is going to be 0 plus 2, 0 take 3, and 0 take 1. Now the point, remember, is not to evaluate it, rather the point is just to determine is it positive or negative in this region. So at the top I have 2 times minus 3, and at the bottom I've got minus 1. I've got minus 6 on minus 1. It does evaluate to positive 6, but the significance of that is that it's positive in this region. Okay, if I'm going to choose a number between 1 and 3, I'm going to choose the number 2. All right, when x is 2, and we've actually already evaluated this. We did it here. We saw when x is 2, what does the function evaluate to? That was part A. So we can use that. When x equals 2, the function is minus 4. And if you want, you can reference it from part A. All right, it's very clear how you've arrived at that. And so what it means is it's negative in this region. Okay? All right, you can put in x is minus 3, and you can put in x is positive 4. All right, so I'll leave those 2 bits for you guys to fill in. We'll move along. All right, so hopefully we're starting to feel a little bit familiar with the things we're working through because we've done them more recently, right? The lines we did a fair while ago now. So let's have a look at question 5. All right, so we're up to question 5. Maybe we'll just jump back to the checklist quickly. So if we look at 3, actually we'll do this next question and then we'll jump back to it. All right, so question 5. So have a look at the graph. It says, consider the graph below. It's this one it's talking about. And we've got this coordinate is minus 1, 7. This coordinate is 3, minus 9. And we've got x-intercept 0. And so that's at 0. And then this is at 6, 0. X is 6. All right, so there's the graph there. Does it display a function? All right, so a function is a special type of relation such that each x value has one unique y value, right? And we check by doing the vertical line test. You just drag your arm across it, and as long as it only crosses it once, it's a function. If it crosses it more than once, it's not a function, but a relation. So here we can see as I move my arm across, it's only crossing the curve once at each occasion. Look, I'm going to draw these lines. Each line I draw only crosses the curve once. Each vertical line has to be a vertical line. So we're going to say yes, function. All right, so some nice easy marks there. All right, next it says state the domain and range. State the domain and range. So the way I'm going to explain this is exactly the way I did when we taught it. All right, I'm going to do it the really long way. Maybe from looking at it, you can see what the solution is. But we say, what is the point? Let's start with domain for x values. What is the point furthest to the left? And so I'm looking left. I'm looking left. I'm going on this whole thing. What's the point furthest to the left? Here, minus 1. So we've got minus 1 less than or equal to x. Less than or equal to because the dot is coloured in. All right, so that's for domain, minus 1 less than or equal to x. And then we look to the right. What is the point furthest to the right? If I keep going the whole way along there, it's got the arrow, which means it's going across and up forever to infinity. All right, so we'll chuck an infinity there. Okay, and then, so whilst you've answered it, we haven't expressed it in the correct technical manner. So what we need to do in the next step is drop the infinity. And then we always need our variable on the left, right? And so we're going to rotate this statement. We're going to flip it. And so we have x greater than, the arrow flips, x greater than or equal to minus 1. Now, this isn't a necessary process, right? All we're interested in here is the statement. And so if you can see that from the graph, you get full marks just for making that claim, right? And you can see it's true on here. What is it saying? It's saying every x value on this functional relation, we've determined it was a function, is larger than, that's what that arrow means, larger than, it exists for values greater than or equal to minus 1. So it exists at minus 1, and it exists for all values larger than. So that's domain, all right? For the range, do I need to make the same argument? I'll make the same argument, okay? So we say, what's the lowest y value? That's the difference with range. As we go, what's the point lowest furthest down? Y is minus 9, all right? So it's not this point. Some people go, oh, they get confused with the domain range. Domain, left to right, range, bottom to top. All right, so we're going to go from minus 9 is the lowest y value. It's included. And then we've got, this is not the highest y value because this arrow tells us it's going up forever to infinity. So less than or equal to infinity. We drop the infinity, and then we need the variable on the left. So the statement will make y is greater than or equal to minus 9. Okay, and so what does that mean? For this function, it exists for values of y larger than or equal to negative 9. Okay, draw a sign diagram. All right, so for a sign diagram from a graph, they're a bit easier. All we're doing is considering the roots. All right, so we have a root at 0 and we have a root at 6, and we can see it is above, below, above. All right, so they're nice, easy marks to get a sign diagram from a graph. Where it's a bit trickier is when you need to make the manual argument, right? Where you need to go through and check those numbers yourself. Okay, so we've got a sign diagram from the graph. Okay, then we've got what we did in 3F. So this one's talking about the transformations. So we might just talk about the first one, f of x plus 2, f of x plus 2. So if this is the function, all right, this is f of x, and I have f of x plus 2. What is it doing? But it's going to add 2 to every y value. So this value here gets moved up 2, this value here gets moved up 2, this one here gets, everything gets moved up. The whole function gets vertically translated 2 units up, plus 2. It moves it 2 units up. All right, so you can sketch it like that. We can just write on moves it, rather than drawing it, let's just write the effect that it has, I think. Let's just label the effect as. Okay, so that's part D, onto E. We'll do these and we'll just talk about what's the effect it has. We have 2 f of x, 2 f of x. So now, what does this mean? It means 2 times f of x. What is f of x? F of x is the y value, 2 times every y value. Every y value is being doubled. This is a vertical dilation rate. So here, if we double minus 9, we're doubling the y value. This point's going to be at minus 18. What about this point? If we double 0, the y value stays as is, all right? And so 2 times f of x is stretching it further away. It's dilating it by a factor of 2, okay? And then f of minus x is what we call the reflection in the y-axis, all right? So I might sketch this one to demonstrate it. If this is the function, all right, the reflection in the y-axis is going to be what happens if you mirror it over the y-axis. So it'd look like this, wouldn't it? That point would be there. They meet here at the same point, and then it would go like that. This one is the reflection about the y-axis. It's the mirror image of it. Okay, so in the test, maybe we'll make our way, hey Jazz, we'll make our way through the next couple of questions, and I might show you a bit at the end of what it's going to look like in the test. Okay, almost done. On to question 6. Consider the circle with center 4, 3 that touches the x-axis. Consider the circle with center 4, 3 that touches the x-axis. Find the circle in expanded form. All right, so for you to unpack, what is this asking? It has a center, x is 4, y is 3. So across 4, up 3. That's its center, and it touches the x-axis. All right, so its radius here is not told explicitly to you. It's something that you need to unpack from a visual understanding of the question. This is 4, 3, and it touches the x-axis. Who can tell me what's the radius?
3.
3, very good. The radius is 3. And so the equation of this circle then is x take 4 squared plus y take 3 squared. Okay? Take 4, take 3, and that's equal to the radius squared. Alright, so that's the circle in Cartesian form. We're asked to find it in expanded form. So we're going to expand both of these using the perfect square rule. So I'll do it quickly. If it's a skill you need to practice, it is going to be asked. So it's a squared take 2ab plus b squared. Alright, so I've done the expansion in one step. Alright, if you're a little bit alarmed there, put a mark there, say that's something I need to practice. And then we're just going to collect them all together, aren't we? So we've got x squared take 8x plus y squared take 6y. Here I've got 9, and I'm going to subtract 9, they're going to cancel. And so we're left with this positive 16 hanging out there. Okay, that's it in expanded form. Okay, the next part D says, does the coordinate x is 5, y is minus 1 lie in the circle? There's 2 ways to check it. Well, there's sort of 3, I suppose, but two efficient ways to check it. First is just to plot it. X is 5, y is minus 1. That's going to be there. Okay, so you can see graphically that this coordinate does not lie in the circle. All right, so we can see it graphically. There's another way we can confirm it as well, which is by substituting these coordinates into here. All right, so let's do that. Let's sub in x is 5, y is minus 1. So I'm going to have 5 take 4 squared plus minus 1 take 3 squared. All right, so I'll put the x. Put the x where the x is, put the y coordinate where the y is. Let's evaluate this. We're going to have 1 squared plus 4 squared. So here we've got 1 plus 16, we've got 17. And so have a look at this statement. I have 17 equals 9. When I put this coordinate in, I got 17 equals 9. Now, firstly, it's not a true statement. The number 17 is not equal to the number 9. But the point of it is that this is larger than 9. And so because it's larger than 9, that means it's outside of the circle. What do you anticipate would be the case if it was less than 9? Inside the circle. And what about if it equaled 9? On the circle. Very good. So we've got outside if it's larger, inside if it's less, and on the circle if it's equal. So that's another way you can check other than using a graphical method. Very good. Let's move on to our last question. All right, so we've got f of x is 2x plus 3. G of x is 4x take 1. Find x such that f of g of x equals 9. All right, so we're solving for an x value here. We want to find x such that this statement is true. Well, the very first thing we have to do is find the composite function f of g of x. F of g of x means f is going to gobble up g of x, right? We're putting g of x inside f of x, like that one. All right, so what that means is f of g of x is going to be 2 times the whole g of x function. 4x take 1. All right, 2 times g of x, and then we have this plus 3 hanging out there. So let's evaluate this first. Let's simplify it. We're going to have 8x take 2 plus 3. We'll have 8x take 1. Now, our question says, find when this equals 9. Find x such that f of g of x equals 9. So we're going to just make it equal to 9. And we're saying, what's the x value that makes this true? We have 8x take 1 equals 9, and we need to break it down. We're going to add 1 to both sides. We'll have 8x is 10. How do we get x by itself? Divide both sides by 8. X is 10 on 8. You can write it as 5 on 4. 1.25. We'll accept either of those. All right, so that's all of those skills that we've just been through is everything that can pop up in the test. All right, so hopefully as we got towards the end of it, you sort of started to feel a bit better, a bit more confident in it, but some of the early stuff I think was pretty far from our mind. But hopefully going over it together sort of gets those cogs turning and reminds you of it. So if you found this really easy, fantastic. If you found it pretty challenging, it might be something to have a bit more of a go at, like just repeat it yourself tonight. This is a pretty good resource. And again, reflecting on those checklists. What are areas I've got mastery over? What are areas I need to practice? So where we'll direct our efforts now then, it's up to you what you would like to spend the next 15 minutes doing. But the chapter review set questions, they're going to be different questions that we haven't asked you yet, that sort of recap the unit, and I've got the ones I recommend doing listed at the bottom of the sheet. So are there any questions for the group? All right, so it's been an intense lesson. I'm pretty exhausted, but that's everything, all right? That's everything in the unit. That's everything we need to know. So I'll stop there and I'll come around and see